With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is the time period of a bar pendulum when suspended at distance 30 cm and 50 cm from its center of gravity comes out to be the same. If the mass of the body is 2 kg, find out its moment of inertia about an axis passing through first point. Suppose A is my first point and B is my second point and CM is the center of mass, and the distance of A and B from center of mass is given as L1 and K square upon L1. Okay, so this is the distance which is given as L1. This is L1, that is given as 50 centimeter. This is the distance of A from center of mass, and this is K square upon L1. This is the distance of B from the center of mass, that is equals to 30 centimeter. This is actually given as 30 centimeter. Now I can write when K square upon L1 is 30 cm, K square upon L1 is 30 centimeter. That means value of K square will be 30 into L1, and L1 is given as 50. So I can write 30 into 50 and changing centimeter into meter. So it is 10 to the power minus 4 meter. Okay, this is the value of K square, and L1 is given as 50 into 10 to the power minus 2 meter. Now we have to calculate the moment of inertia of the first point of A. That means moment of inertia at point A with respect to the center of mass can be written as, this is the moment of inertia at point A. This is the first point about the center, or passing from the center of mass, can be written as mk square plus m L1 square. So now I have the value of K square as well as the value of L1 square. So putting the value, this is IA. Okay, moment of inertia at point A about the center. So I can write that is equals to M. M is given as 2 kg, and the value of K square is 30 into 50 into 10 to the power minus 4 square plus M L1 square. M is 2 and L1 is 50 into 10 to the power minus 2 of square. After simplifying this, we will have moment of inertia at first point, that is A, is coming out to be 0.8 kilogram meter square. This is the moment of inertia at first point about the center. Okay, 0.8 kilogram meter square. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.